So my understanding of row-level locking within serializable transactions in MySQL is continuing to evolve. In a previous demo, I used this table widget that has an index on user ID to demonstrate that row-level locking is limited to a particular user ID when reads are made or selects are made inside of a serializable transaction that leverages this particular index. Now, it turns out that it's actually a little bit more complicated than that when a particular slice of the index for a user ID doesn't have any rows associated with it, meaning there are no rows in this widget table associated with a given user ID. Row-level locking around that user ID gets a little bit more expansive and can actually cause deadlocks in situations that I might not have expected. So to demonstrate this, I have a Cold Fusion file here, a Lucy CFML file, and we're going to have two users, Sarah and John, and we're going to truncate that widgets table that we were just looking at so that it has no rows in it whatsoever. And then we're going to spawn two threads, one for Sarah and one for John. And both of these threads are going to have the exact same logic. They're going to enter a serializable transaction. They're going to check to see if a widget already exists with that name for that particular user ID. And then, as per my previous demonstration, that is going to create locking around all of the rows for this particular user. And then we're going to try to create a widget all inside the serializable transaction. You can see that both of these are the exact same code. Inside each of these transactions, these serializable transactions, we have a sleep for 500 milliseconds, and that's to ensure that both of these competing threads spawn and enter this transaction before they both try to create a widget. And then at the bottom, we're just going to dump out the widgets for those particular users. So again, we have two users. We're going to empty that table completely, then spawn two threads for two different user IDs and see what happens with the row level locking. So if we jump into the browser and we refresh, what we can see is that Sarah's widget got created. However, John's widget did not get created. And we can see from the thread error that John entered a deadlock. Now, I mentioned that this is partly because we have a truncated table here, meaning that we have no rows. So if we actually uncomment these two lines of code, and all this code does is create an existing record for Sarah, an existing record for John, and everything else stays exactly the same, and we run this code again, what we can see, if I continue to refresh the page, each one of these serializable transactions executes without a transaction deadlock. And that's because at this point, with existing rows for each one of these users, this read level, this select here, is locked locally to a particular user ID so that we don't end up overlapping our transaction for Sarah with our transaction for John. And that was in the previous demo. And again, if we comment this out so that we start with an empty table and we refresh again, Sarah's widget gets created, John's widget runs into a deadlock. Now, if we come back here and we uncomment Sarah's, but leave John's commented out, let's see, which one is this? This one also continues to get a deadlock, no matter how many times we refresh the page. Again, John's getting a deadlock. If we reverse the order of these comments so that we have John's ID but not Sarah's, and we refresh, this continues to work and we can continue to refresh here and we don't run into a deadlock. And I believe, and this is really over my head in how the database mechanics are actually playing out, I believe this has to do with the fact that John's ID is larger than Sarah's ID, which has to do with how MySQL is actually performing locks around maximum values or paging of indexes. Again, something called supermum. I don't really fully understand. A lot of that is being discussed in this MySQL bugs forum. Because what we can see is, while this works, if we make Sarah's ID larger than John's ID and refresh, then we get back into a situation where we have a transaction deadlock. And again, I believe it has to do with some sort of underlying mechanics in the MySQL database. So I don't think that this is going to immediately change any of my transaction strategies within my MySQL and Cold Fusion applications, but it does at least demonstrate that there is going to be potential for deadlocks in a situation where I might not have considered it, given the fact that I have a user ID based index and I have multiple competing transactions for different user IDs, which once there's data in that table shouldn't have deadlocks, or at least not nearly as often, whereas what we're just seeing, when that table is empty, we invariably get a deadlock when we have two competing threads. So again, just trying to grow my understanding of how deadlocks work and how serializable transactions work and how row level locking works inside of MySQL. And I'm not a database administrator, so I'm learning as I go here, and interesting stuff, I think.